Okay, so we are back from the coffee with some energy. This is Guilherme Rambo. He's a great spelunker. I don't know if you remember, but he found the glyphs of the iPhone 10 before Apple announced it, for example. And this talk is going to be on Spelunking, and I think you will enjoy it.
Thanks. It's really nice to be here this morning, and as you said, my talk is about the art of spelunking. There's some art to it. So I'm Guilherme, and yeah, my name is kind of tricky for some people to pronounce, so I just shortened it. Mr. Rambo. You can call me G if you prefer. And according to the media, I'm all of those things. So, yeah. So before I get started with the meat of my talk, I'd like to mention that we're going to do a live episode of Stack Trace. Whee! Which of you listen to Stack Trace? Nice. We're going to get some more listeners today, John. So we have this hashtag, AskStackTrace, and we are going to be looking at it later on. It's going to be at like 5 p.m., the live show. So if you have any questions for us, if you want to make a comment about yesterday's Apple event, because of course the episode is going to be all about that, just use AskStackTrace, and we are going to be probably looking at it. Before we get started, again, I want to propose a moment of silence. It's a very serious subject, because there's an Apple device that is missing. I think you might have seen it before, maybe. Come on, Tim Cook. I would be very happy today if they had announced it, but they didn't. So let's talk about spelunking, which is the subject of the talk. So I'd like to start with a definition of the word, because not many people are familiar with it. I think the first time I heard spelunking, it was by our dear friend Erica Sadun. I think she is the first person who I saw use the word. And then Casey Lees adopted the word spelunking, and then we adopted the word spelunking, especially John, but then I followed. So according to the Urban Dictionary, spelunking is the act of exploring a cave. But it's really taking stuff apart to find cool things, and that's what I like to do. So every time Apple releases a new software update, before even I install it, I just unpack it and check what's in there. I'd like to start with a story. I think it's good for you to understand my background. So back in 2011, I was working on a subtitle editor for macOS 10, which never shipped. And that's a common theme with my projects. So they had just released Final Cut Pro X, maybe 10, and it had this beautiful UI, this dark UI. And one thing I noticed was, you know the graphite mode on macOS? When you went to the menu bar on the Final Cut Pro 10, it was using the graphite mode, even if your preference on macOS was to use the colorful one. So I wanted to do that for my subtitle editor. And I decided to check out how they were doing it, but I didn't have much experience with reverse engineering, which is what you do when you want to see how something works, and it's not open source. But I knew about class dump. You know class dump? So class dump is this thing that you can pass it a binary from Mac or iOS, and it will basically spit out a header file. So you can check which classes are available. So I ran the Final Cut Pro binary through the class dump tool. And I didn't find what I was looking for, but I found something else. So back then, people were complaining because the new version couldn't open projects from the previous version, and it couldn't even import XML, which was a common interchange format for Final Cut Pro between Final Cut Pro and other apps. But then, doing the class dumping, I found this interesting method. Import Final Cut XML. And that grabbed my attention because I was reading all over the web about people complaining that they couldn't import XML. And there it was, a method called import Final Cut XML. So I decided to go a little bit further and actually attach a debugger to Final Cut Pro 10 and actually call the method. And when I did, this is what happened. So beautiful import XML dialog appeared. And then I noticed that, wow, this knowledge I have about reverse engineering to learn about things can be used to find out about things that aren't even announced yet, because you can find stuff in software. So I ended up submitting my findings to a Brazilian website about Apple, which was the one I read every day, and they published it, and then it was published all over the web, on lots of websites. So this was the moment when I realized that I could do that. Flash forward to 2017. I did some stuff between 2011 and 2017. I learned a lot, but wasn't like super involved in reverse engineering. What happened was that Apple released a firmware for the HomePod, which they announced at WWDC, but it wouldn't ship until December, and ended up being delayed and took longer than that. So many people downloaded that firmware and started looking at it. And one of those people was this guy. You may have seen him before. And then I think it was a Friday, he tweeted this, that he had exhausted what could be found, because he had just found like how HomePod would work, how the little display on top was like an array of LEDs and stuff. And then he said, someone else can poke at it. And I took that seriously. So it was, I think, a Friday. I downloaded the zip file for the OTA firmware and left it on my downloads folder. And Sunday, I was bored, so I decided to have a look at it. And I noticed that the version of iOS which was running on the HomePod firmware, which they had accidentally released, was 11.0.2, and we were testing iOS 11 beta at the time. But there it was, iOS 11.0.2, so it was ahead of the beta. It was another version of iOS. So I remember that I was reading about on the web that the next iPhone would supposedly ditch Touch ID in favor of face detection. So one of the things I decided to try was to see if I could find something about face detection in the HomePod firmware, since it's the same iOS that runs on all devices. So very simple. I just did a quick search for face detect, and then it gave me some matches. It found some stuff in there. So iOS has had face detection for a long time, but as you can see, there's a match in biometric kit. Biometric kit sounds a lot like something that would be used for biometric authentication. And then there's this file at the top there. Hide! So I was clearly onto something here. So yeah, so I decided to take a look at biometric kits using the disassembler, which sounds really scary, but totally isn't. And then I noticed that there was this new class in there. By comparing it with the version from the public iOS build, there was this BK device Perl API in there. And I noticed that it was added, and the other one that was there was, I think, like BK device Touch ID or something. So clearly, this was some sort of new authentication mechanism. And it had something to do with face detection. So yeah, so by then, I decided that Perl was probably the name of the new face detection thing, the code name. And then I decided to look everywhere for, let me go back here, back, oh, delay. There you go. So I decided to look for Perl everywhere, because now I knew the name of the new face authentication thing. And then I noticed this reference that had Perl and D22. So when Apple is working on a new device, they don't call it the iPhone XS or the iPhone 10. They call it some code name, which probably the engineers working on the project don't even know what the name is going to be. So, and I happen to know this from previous Spelunking, and I noticed that D22 looked like a device identifier, and all iPhones at the time, their code names started with N. In fact, fun fact, the iPhone XR that they released yesterday is N84. So N is like the cheap phones, and D is the super awesome phones. So yeah, so D22. So okay, I had, remember, I found face detect, then I found Perl, then using Perl I found D22. So I decided to look for D22, and I found this file: payment glyph phone d22.car. It happens that I had seen this type of file before, .car. They are like an image file format. And it's funny because the HomePod firmware, they had removed all assets from it because HomePod is a speaker, so it doesn't need any assets. But probably the script they used or something forgot to include the car file format. And not to be confused with the asset catalog, which is 1A. This one has 2. And it's just like a vector file format for images, which is key archived core animation layers. So it's just core animation layer hierarchy compressed into a file. And I happen to know how to render one of these files, because by default, you can't just double-click and open them. So I rendered this file, and this showed up on my Mac. Must be very familiar by now. And this was, I was iMessaging a friend of mine, and this was my reaction. Yeah, so he was the first one after me to see it. And if you want to go even further to 2018, there was this thing. You're probably very familiar with this picture by now. This time it doesn't have the watermark. So yeah, this year I happened to found some marketing images of both the iPhone XS and the Apple Watch Series 4. It's a different type of spelunking, not the one I'm going to talk about today. But yeah, that's my story. So let's go practical. Practical guide to spelunking, which could be called Spelunking 101, now that I think about it. So the first step is you have to get the thing you want to check out. So grab a copy of whatever your subject is. Could be an app, could be an iOS release, could be just macOS, which is sitting on your Mac. And if you want to do this with App Store apps, it's a little bit more complicated, so I'm not going to talk about that today. So let's use the example of an iOS release. So if you have a developer account, I guess most people here do, you can go to developer.apple.com/downloads, and you can download a build of iOS for the particular device you want. I like the iPhone X, so I got that one. And it used to be that the IPSW file, which is the firmware image for the device, it was encrypted. And it was very hard to actually decrypt it because it involved keys in hardware and stuff. But for some reason, maybe to help me, Apple decided to not encrypt them anymore. So this means, well, you could always just rename them to zip and extract the contents, because IPSW is just a zip file with a different extension. What you could not do before was you couldn't actually mount the root file system. But now you can. So just rename to zip, extract, find the largest DMG inside the zip. It's usually around 3 gigabytes. Extract it, mount the DMG, and there you go. You have the root file system for the particular iOS build you're looking at. So now that you have your subject in a spelunkable state, you need to find out where stuff is, because you want to find stuff, so you need to know where stuff is. So let's say I want to learn more about how True Tone works. So I can just do the same thing I did for face detect and just grep recursively for True Tone. There are actually better tools than grep, but grep comes built in, so it's quick and easy. Not quick, actually, but it's easy. So you can just do a grep for True Tone. And in this case, I noticed that True Tone has a reference in the Setup app. The Setup app is the one that when you get a new iPhone, it opens up an onboarding experience for you. So I load the Setup app in Hopper, and it looks very intimidating, but it's not. You can select the Procedures tab and check out the procedures, or you can go to Strings, and looking at strings, you can search for True Tone. So I found a reference to True Tone, and then you can use the cross-reference tool to find out like that there's a buddy harmony controller. I love the class names they use. Fun fact, the setup experience is called Purple Buddy. So that's why they have Buddy in the name. And there's also a framework, Setup UI, and the classes have the cutest prefix, BFF. So cool. So there's a reference to True Tone in Buddy Harmony controller. So I happen to know that Buddy is just like a generic name for the setup thing. And controller, we all know what a controller is. Harmony. So we can infer, based on this, that harmony is what true tone is called internally. So that's the code name for true tone. As with the devices and with Face ID, which is Perl, basically all features, all new features have a code name. So, and this is how you find the code name after it's been released. To know about the code name before it's released, it's a little more tricky because you have to like find a new name you had never seen before and try to learn what it does. But if you want to study something after the fact, this is how you do it. And you can then start searching for harmony because now you know that harmony is the name and you can find everywhere where harmony is referenced. An optional step is to actually attach a debugger and poke around. This is very tricky to do on an actual device, but because you need jailbreak and stuff. But if you want to do something with an app that's available in the simulator, such as, I don't know, the Messages app or the Settings app, you can just attach to it, and I'm going to show it to you in a demo. The tools I use mostly are Hopper, which is like for me the best disassembler for macOS. And it's not only a disassembler, but it has this cool pseudocode view, which can be helpful sometimes. And you can search for strings with it. You can see cross-references to methods and stuff. So it's really powerful. You can also use class dump, which I mentioned before. Very useful if you want to call into private APIs to basically generate a header. There's this really cool project called Cycrypt, which will let you basically connect a very powerful debugger to your device. And as with the regular debugger, this requires jailbreak, so it's a little bit more advanced. But if you want to, let's say, mess with your own app, you can embed the Cycrypt framework, and you basically get a console that you can type commands in and mess with your app. And these pair of tools here, the simulator and LLDB, since the simulator runs on your Mac, you can do anything you want with it. In fact, my demo today is going to be about how I was able to do this post for a 9to5 Mac. We noticed that the HomePod UI was mentioning the ability to make phone calls in iOS 12. And this was running the HomePod setup UI in the simulator. So we were able to make this post and confirm that it was coming with iOS 12 because it hadn't been announced. It was just a rumor. So let's do the demo. It's supposed to mirror my display. Nope. Nope. Someone call Apple. Apple Care. Of course, I disconnected the wrong one. Yay! Technology. I love it. All right, so Command plus. Oh, it's so fast when it's Object-C. With my Swift projects, it lags a lot when I do Command+. All right. Spoilers here. So, what I have here is a project I created. I call it B238 Presenter. And the way I name it like this was that I was looking at the runtime route for the simulator. So the simulator is just simulating an iOS device, and it has its own root file system, which they call runtime root. And the easiest way for you to find it is for you to go into your applications, Xcodes, and you just do find, and you have to specify the directory, of course. So this is the easiest way to find it, because as you can see, the path is quite long. So I just do this, and I actually saved it on my sidebar in Finder. So as you can see, you have a runtime root for the Apple TV OS. You have one for the iPhone OS, iOS, and you have one for watchOS. So today we're working with the iPhone one. So this is the runtime root. It's probably very familiar to you. It has an applications folder, library, system, so basically the OS. And I have here, thanks to my dear friend Paul Hudson, I have the GM of iOS here, which he downloaded for me. And as you can see, so this is the actual code that will run on the device, so the actual root file system, and this is the runtime root. So you can see they are very similar. They have some similarities. And the runtime root has an applications folder. And there are lots of applications here. So there's contacts, which is the app contacts. There's FaceTime, there's files, so lots of apps on the simulator. And you may have noticed that there are some apps here which are not available in the simulator. Like, what the hell is AirMusic? AirMusic is actually the music app that runs on HomePod. Same for AirPodcasts. But these are not actual apps. They're just like placeholders. They are there for some reason. I'm not sure why. There's no executable. But I found this very interesting named app here, which is called Sharing View Service. And of course, this is not an app that we actually run by tapping an icon. So many of these apps here, they don't actually have an icon on the home screen. They are internal apps that present UI on top of other contacts. Like when you have the AirPods and you open up the case next to your iPhone, there's this little pop-up that shows up. That's a sharing view service doing that. And the same happens for HomePod. You can see here there's Safari view service, screenshot service, shared web credential web view service. So yeah, there are lots of those view services apps that just draw UI on top of other apps. And it's actually pretty cool. So let's show the package contents for the sharing view service here. So we have lots of images here. So there are some images that it uses, and this is a very nice place for them to leak the next iPad or something, because we have images here. That's usually not how it happens. They are not that naive. There's even a video here for the AirPod stuff. So it's an app. It's an app that we don't run by tapping an icon, and as with any binary, we can disassemble it. So let me fire up Hopper which is a phrase I say very frequently. And I'm going to disassemble the sharing view service here. So it's doing its thing, and it's done. OK, so we have this stuff here, which looks like gibberish. And we have this sidebar, and we have here the strings. So if I want to search for, I don't know, AirPods, there's AirPod stuff, AirPower. So sad. And here we can see the procedures. So procedures, they are basically the classes, methods, stuff like that. So you can search for stuff. Let's say I want to find some view controller. Let's search for controller. Oh, so there are some view controllers. Apple TV setup main controller. Sounds promising. Apple TV setup room picker. Oh, B238 setup main controller. What's B238? Let's see. B238. So the B238 setup main controller has this show stereo pair picker UI method. So I'm guessing this has something to do with HomePod. And I think that's for sure. And I happen to know that because I know that HomePod is B238, so this is all scripted and it's all fake. But yeah, I know that it's HomePod. So I made this project called B238 Presenter. It's actually very interesting that they ship this sharing view service with a simulator, because you can't pair a HomePod with the simulator. I don't know, maybe you can, but we are going to simulate it. That's what the simulator is for. So I have the iPhone 10 simulator running here. And this project is a framework that I made. And in the build phases, I added a run sharing view service. And there's this really cool command. You can run xrun simctl launch booted, and then you pass it a identifier for an app. And this one is com.apple.sharingViewService. That's the bundle identifier, which you can find in the info.plist. It's right here, com.apple.sharingViewService. So this command will allow you to run something on the simulator, even when it doesn't have an icon. And I can run it here just to prove it. So, wow, so beautiful. Brand new iPhone Black. So sharing a view service is an app that's supposed to draw UI on top of other apps. So it's not meant to be run like this, but you can actually run it like this. But we have to make it do something. How do we make it do something? To make it do something, we can attach a debugger to it, LLDB in this case, and just write Object-C code. And to make things easier, so I don't have to write everything in LLDB commands, I made this framework called B238 Presenter. And what I'm going to do is I'm going to load my framework into sharing view service and make it do stuff. So let's use the power of the debugger. And I'm actually going to just build my project, which starts sharing view service. And I set up to attach with the debugger here. So it's just like we are running sharing view service. So we can pretend we are Apple and we made sharing view service. And it's running here on the simulator. So now I can pause it. And I have this command I can run. Ooh, so now it's showing me a wallpaper thing. Well, this is actually my code running. I made it present a view controller with a background, just so it looks prettier. You know, we're hacking stuff, but doesn't mean things don't need to look pretty for the pictures and for the 9 to 5 Mac post. And the way I decided to interact with my hack was with gestures. So I set it up that if I make a swipe from left to right, it's going to show the HomePod setup UI. So I'm going to do that right now. And suspense. It's going to show up any minute. There you go. OK, so now I have the HomePod setup UI. It's showing this generic icon, not the HomePod. We're going to fix that later. And I can set up my imaginary HomePod, just like if I had a HomePod. OK, I don't want a stereo pair this time. I'm going to pick the best version of English. OK, I agree. Huh. What's that? How will you be using this HomePod? Well, I guess that's something that's for Apple internal people only. I'm going to be using it for development, of course. And all of those HomePod apps. Transfer settings. OK, so my HomePod is set up. Yay! So let's dig into this in more detail. Let me show you what I have here. So B2Trade Presenter is just a framework like any other. And I created this class called HomePod Setup. And excuse me for the hacky code, but come on, it's a hack. So it's an interesting situation because what we usually do is we link with like UIKit, public framework, and we have the headers. So we use the headers provided, and we have the classes and stuff. But this is different because I'm doing the opposite. I'm taking a framework and injecting it into a process, and I want to use the stuff from that process on my framework. So it's kind of interesting. But we can leverage the runtime, the Object-C runtime to do that. You'll see as soon as my bundle, which is my framework, is loaded in Sharing View Service, I have access to everything Sharing View Service has. And this is why you shouldn't put any SDK into your app, any random SDK, because any framework that's linked with your app has access to everything your app does. So if your app has permission to access the user's location, the user's contacts, the framework you're linking, which could be a random shady framework from some weird shady company, it can access anything your app can access. So be careful about that. So what I did is I used class dump, and I dumped some of the classes and methods from the Sharing View Service app, including the B2Trade setup main controller, which we saw earlier. And it has all of these methods. And then down here, I have these methods very appropriately called run. And when I call run, I set up some states, and I set the status bar style for the app. You know, it has to look pretty. I create a background controller, which I made to display the wallpaper. So this is the entire setup here, the wallpaper. I got the image. And so this is just regular iOS stuff. And then I create a window, because Sharing View Service, by default, it doesn't have a window. Then I put my controller into the window, and I make the window visible. So far, regular iOS stuff. It's just that we are running it in another person's app, not ours. And then I install some gestures. So I add a tab gesture. I have a swipe right, so a swipe down, and a swipe left. So the ones we're going to use today are these two. So when I swipe right, I want to call the handle swipe right method. And what this one does is it calls this present setup controller with class name, which is another method I made, and I pass it the B2Trade setup main controller name, which is the name we found earlier. And the implementation of it uses NS class from string to actually grab the reference to the class, because remember, it's running inside sharing view service, so all classes in there I can access. But I can't put like just the name of the class here, because we're not linking with anything, so it's going to fail to link. But since Object-C has this amazing runtime, we can instantiate any class just by its name. And then I configure this controller. It's just a UI view controller. I set some stuff in here, not particularly important. And I have this special screen modes. This is a thing I made to be able to present specific sub-steps within the setup process. And it's very hacky code. It could be an enum, some switch statement or something, but it's just this. And as you can see, with a special screen mode equals to 2, it's going to show the personal requests UI, which is that UI where it shows how you can make personal requests to HomePod. And the way I set special screen mode is when I swipe down, it's going to increase special screen mode and also present alerts just so I know which mode it's using. So let's try this special screen stuff. So same process as before. OK, so swipe down. Special screen mode 1. Remember, the personal request one was 2. So let's do 2. And let's swipe again. So it's going to present the UI, and then it's going to switch to the personal request screen. And as you can see here, make phone calls is there. And it wasn't before. And this icon here is blank because it's the phone app icon, and the phone app is not in the simulator. So that's why it's blank here. So as you've seen, when I do the setup thing, it shows a generic icon, which is this unsupported accessory icon here. But we can fix that. So the way they present the beautiful videos and images for devices is those are downloaded from Apple servers, and some of them actually come pre-installed with the OS, and they are just bundles, and we can find them here in the real iOS build under System, Library, Pre-installed Assets v2, required by OS, com Apple, blah, blah, blah. And there's these weird .asset things here. And as you can see, this is for AirPods. And this is for audio accessory. And there's a nice video in there. So what I've done is I actually pasted this path because the simulator can access any content you have on your Mac since it's running on your Mac. So you're not limited to the runtime route. So there's this method which I found inside the sharing view service, which is get asset bundle for device query timeout with completion handler. So what I've done is I implemented this method on my B238 class, my HomePod setup class. I instantiate a bundle and I pass it the path. So I took it from the iOS 12 beta 12 and I put the whole path in here. So I'm returning the audio accessory 1.1 color 2 device bundle. And then I'm calling completion with the device bundle and new. So I inferred that most completion handlers on iOS and on the Mac, they are 2 parameters. The first one is the thing you want or nil, and the second one is nil or an error. So I just guessed that it would be that, and turns out it was. And when my class is loaded by the runtime, I'm going to call this method swizzle device bundle. So what I'm doing here is I'm using the Objective-C runtime to switch the implementation of the get asset bundle for device query timeout with completion handler method by my implementation. So then it's going to actually see the device bundle. Let's see if this works. I hope it does. All right, so let's do the thing here. I have to attach the debugger, of course. And there you go. Beautiful animation. As you know, I love beautiful animations. So thank you very much. It was really fun to present to you, and I hope you liked it. These are my online thingies on GitHub, @_inside on Twitter, and I'm writing for 9to5Mac as well. Thank you very much.